Okay, today we are just doing more of what we did basically in the last set of notes. We're just going to look at some more problems. Some are kind of the same as the last ones, and some are a little different than the ones you saw in the notes before. Okay, let's look at number 1. One number is 6 less than 5 times another. Their difference is 22. Find the numbers. Okay, I am going to let x represent the first number, and I'm going to let y represent the second number. And of course, you could use any letter if you wanted. Okay, let's look at this first sentence. One number is. So when I read one number is, I'm going to have x equal, and then it says it's 6 less than 5 times another. Do we have any switch words in that? Yes, less than is a switch word. So I start with the back of the sentence, 5 times another, meaning 5 times the other number. So that would be 5y. Less than means minus, and then I come back to the 6. This is how you say one number is 6 less than 5 times another. Okay, the second sentence says their difference is 22. And what does difference mean? Difference means to subtract. So if you subtract the numbers, you get 22 as a result. So x minus y equals 22. Okay, let's talk about solving this by hand. If I were to solve this by hand, what method do you think might be the best? I would say substitution. Bread meet bread. And that's because we have an isolated variable. X is all by itself in this equation, and it's ready to plug in. So substitution, or bread meet bread. And if I were to do this with matrices, I do want to talk about that because I want to make sure everybody knows that skill. So my second equation is find the way it is, because it's got the x and the y both on the left-hand side. My first equation, though, I would need to get that 5y over to the left-hand side. Remember how I would do that? I would subtract it. So if I subtracted 5y from both sides, I want to write the x first and then the y, so you can see it's a positive x. You can see it's a minus 5y. And on the right-hand side, all I have left is negative 6. This is how I would put it in the calculator if I were going to use the matrices. Okay, number 2. The perimeter of a rectangular garden is 46 feet. The length of the garden is 5 feet less than 3 times the width. Find the length of the garden. Okay, I am going to use L for my length, and I'm going to use W for my width. In this sentence here, I'm told that the perimeter of the rectangular garden is 46 feet. Remember, our formula for perimeter of a rectangle is 2 times the length plus 2 times the width. And I do happen to know that the perimeter is 46 feet, so I can put a 46 where the P is. So I'm going to go ahead and put the 2L plus 2W on the left-hand side, and then equals 46. Okay, second sentence. The length of the garden is, so what letter are we going to use for length? L. So length is, so L equals 5 feet less than 3 times the width. Any switch words in that? Yep, less than. So let's start with the back of the sentence. 3 times the width. How can I write 3 times the width? 3W. What does less than mean? Subtract. And then I come back to the 5. And this represents the length is 5 feet less than 3 times the width. Okay, let's just solve this one by hand and talk about how you would solve it by hand. If you were to solve by hand, what would you use? Substitution. We have an isolated variable. The L is all by itself. So I'm going to use substitution, our bread meet bread. Remember, wherever the letter is by itself, wherever our variable is isolated, that's the bread. So L equals 3W minus 5. That's the bread. The meet's the other equation. The 2L plus 2W equals 46. And then I come back to the bread. The L equals 3W minus 5. So I want to make sure that you guys don't forget how to solve these by hand, even though you have seen some calculator tricks. So if this is what L equals, where am I going to put it? Into the L. So it's going to be 2 times L, which is 3W minus 5. Then I recopy the plus 2W, the equals, and the 46. Next thing I want to do is I want to distribute. So 2 times 3W is 6W. 2 times negative 5 is negative 10. And then I recopy. Remember, whenever you have like terms on the same side of the equals, you get to combine them. So 6W plus 2W makes 8W. I bring down the minus 10, the equals, and the 46. Then what would you do? You would add 10 to both sides. That makes 8W equals 56. And if you divide, what do you get for W? You get W equals 7. Okay, if this is what W equals, where am I going to put it in this equation? Into the W. So it will be 3 times 7 minus 5. 3 times 7 is 21. 21 minus 5 is 16. So the length is 16. Okay, so it actually wanted to know what's the length of the garden. So the length is 16, and this is in feet. And we found the width to be 7, but the only thing it asked for up here is to find the length of the garden. So that's all I answered, was the length. That wasn't so bad. Okay, number 3. For their season opener, the freshman basketball team sold 90 tickets for a total of $334. Adult tickets for the game cost $5 and student tickets cost $3. How many adult tickets were sold? Okay, this is kind of like one we saw the other day where we had a money equation and a total equation. So that's the same kind of problem this is here. We are talking about adult tickets. So I'm going to use an A for adult tickets, and student tickets, I'm going to use an S for my student tickets. Okay, let's talk about the total equation. The total equation wants to talk about how many total tickets were sold, and when they sold a total of 90 tickets. So many adult tickets were sold, plus so many student tickets were sold, and that makes a total of 90. A plus S equals 90. Then we have a money equation. How much everything's worth. The adult tickets cost $5. So that would be 5A. Plus student tickets, those cost $3. So that would be 3S. And how much money did they make total? $334. This is the money equation. Cha-ching! How much for adult tickets, how much for students, how much total money. This is just a total number of tickets up here. Okay, if I were to solve this by hand, the best method would be elimination. I don't have any isolated variables, so elimination is what I'd want to use. However, if I was using the calculator, I would do this with matrices because that would be super easy as well. Sorry, I keep belching a little bit because I am having a beverage of Dr. Pepper. Can you see it? Dr. Pepper. All right, I know you're all jealous now. Sorry about that. Moving on. All right, Miss Jill. She collects nickels and quarters. Her bank now holds 30 coins with a total of $5.10. How many quarters does she have? Okay, we already saw a coin problem just the other day, so this is very similar to that. They're talking about nickels and quarters, so I'm going to use N for my nickels, and I'm going to use Q for my quarters. Okay, how many total coins does she have? She has 30 coins total. So some are nickels plus some are quarters. That makes up 30 total coins. Okay, how much money is everything worth? Nickels are worth 5 cents, so that's 0.05 N. Quarters are worth 25 cents, so that's 0.25 Q. And how much money does it say she has? $5.10. This is our money equation. How much nickels are worth, how much quarters are worth, how much money. So if I were to solve this by hand, I would say elimination is what I'd want to use. If I had the opportunity to use the calculator, then I would do matrices. And it's already set up for the matrices. We've got the N, the Q, the N, the Q on the left-hand side, so it is ready to go. So I'm not actually going to solve this one, because if I had to solve it, I would definitely just use matrices. No big deal to do it by hand, but matrices, now that you've seen that, that's how I would do it. And I'm just going to not do that right now, because that involves the calculator, and you guys can't punch it in along with me, so I'm just going to move on to 5. Jason and a group of his friends went out to eat pizza on 2 different occasions. The first time, the bill was $21.14 for 4 sodas and 2 medium pizzas. The second time, the bill was $39.70 for 6 sodas and 4 medium pizzas. What would the bill be for 1 soda and 1 pizza? Okay, so we're talking about sodas and we're talking about pizzas. So I'm going to use S for sodas, and I'm going to use P for pizzas. Okay, this one's a little different than the last couple problems because each sentence is about money. The first time, the bill was $21.14 for 4 sodas and 2 medium pizzas. So I can write that 4S, that's for the 4 sodas, plus 2P, that's for the 2 medium pizzas, and that cost $21.14. There's one of our equations. The second time, the bill was $39.70, and that was for 6 sodas and 4 medium pizzas. So 6 sodas, 6S, plus 4 medium pizzas, 4P, and that is $39.70. And I would just do this with matrices. But if you wanted to solve it by hand, we could do elimination. And I'm not going to go ahead and solve it. We're done here, folks. Smiley face.